Welcome back, folks. In this video lecture, I'll be talking about some more problems from the chapter number 4. And in this one, we are given these diagrams, and we're trying to find out the reaction loads A and B. So I'm going to do this one and this one. That's what I'm going to do. And then I will recommend you guys to try and do as many as you can from this, just as a practice. So let's start with the example 4.49. So we are given this diagram and we wanted to find the reaction load. So this is a pin load. First one is a pin load and this is a roller load. So if I draw a free body diagram, that's how the free body diagram is going to look like. So this will be Ry, well, Ay. I will call it as Ray, reaction loads at point A in the Y direction, and this will be Rax, reaction load in the X direction at point A. And here there is another load that we're going to call it as Rby. Now, in this diagram, if I see carefully, all the loads acting onto this beam are in the vertical direction. I don't need this one. So whenever the loads are straight up in the vertical direction, then this will become irrelevant. If one of the loads, so for example, if this 4 kilonewton load was like this, then I would have needed the Rx. Okay, so if you see in the solution book that there is no Rx, they haven't taken the Rx because there is no inclined load, means there is nothing acting in the horizontal direction, everything is acting in the vertical direction. All right, so I'm going to erase the Rax and I'm going to show the other loads which are acting on the system. So this is 3 kilonewton, and then another load acting here is 5 kilonewton, and then the third load acting down here, which is equal to 4 kilonewton, acting at this particular point. Now, if I measure the distance, so this distance is 1 meter, 1 meter, and this distance down here is 6 meter, and then this distance given to me is 2 meter, and here the distance given to me is 4 meter. All right, so remember the moment. So clockwise moment is negative, and counterclockwise we take it as positive. So if something is rotating in this direction, we'll take it as negative. Something is rotating in the opposite direction, we'll take it as positive. So I'm going to take the moment about point A, taking moment about A. Just let me quickly check whether it's being recorded or not. Yes, it is being recorded. All right, so if I take the moment about point A, and then this load is trying to rotate it in clockwise direction, so about point A. So 4 times, I'll write it 4 times 9 with the negative sign, and this 5 is trying to rotate it in the clockwise direction also, so I'll write it as minus 5 times 2, and then this 3 is trying to rotate in the counterclockwise direction about point A, about this point. So I will write this one as plus 3 times 4, and then plus RB. RB is trying to rotate it in counterclockwise direction, so I'll write it as RBY, RBY multiplied by 8, because 6 plus 2 is 8, is equal to 0. So this is going to give you minus 36 minus 10 and then plus 12 plus 8 RBY equal to 0. Once you're going to solve this, you're going to get the RBY value equal to 4.25, and this value will come out to be a positive number. So the direction of the load, whatever we've taken, that is the correct one. So we've taken the direction as positive, so we'll keep it as this one. All right, if by chance this value would have came out to be negative, then I would have shown later on in my final answer, I would have shown it as RB as 4.25 in the downward direction. That's how I would have shown it as if this was a negative number, but right now it is a positive number, so I'll show it as upward. Positive means upward. That's how we're gonna show this number as. All right, so this was for RB. My computer screen got stuck somehow. I don't know why. hopefully it won't ask me to make it a newer one. So let me just quickly check. Hopefully I will be able to keep moving. Okay, I'm going to erase this and make some space here, and we'll try to find the B force also, because right now my computer screen is stuck. I cannot move. All right. So let's see this. All right. Oops, it started moving. Great. Now taking the moment about B, taking moment about point B. So this is the point about which I'm going to take the moment. And if this is the point, so this is rotating 5 kilonewton is rotating it in the which direction? Counterclockwise direction. So 5 times 6, and this 4 is rotating it in the clockwise direction. So this value will be, we are taking the moment about B. So I will take this one as 4 times 1, which will be a negative number. And then there is this 3 kilonewton. This is rotating it in the counterclockwise direction. So this value will be 3 times plus 3 times, the number is 6 plus 2, 8, 8 plus 4, that is 12. So that will be the number. And then ry, ray, this number, this is clockwise. This will be at a distance of 6 plus 2, 8, 8, and this will be a negative number. So that's how we're going to write it. And this is equal to 0. So this is 30 minus 4 plus 36 minus 8 ray equal to 0. 30 plus 36 is 66, minus 4 is 62, minus 8 ray, and 62 equal to 8 ray. Dividing both sides by 8, I will get the value as 7.75. Again, this number comes out to be positive, so I'll show it as upward direction. So I am emphasizing on these directions because in test they've asked you. So please make sure you learn how to put the direction. So it's 7.75. This is a positive number. So direction, I've taken it as up because with it's in y direction. So y direction can have upward or downward direction. If it was negative 7.75, I would have written it as 7.75. Negative means down, like this. Okay, so there are marks for the directions in the test. So please make sure you put the directions carefully in the test. All right. Now, the next question we're going to do, that is this one, 4.54. This is the one I'm going to do. And this is a little bit tricky. So what we need to do is we need to convert all this distributed load. This load is distributed over a span. So I need to convert it into point loads so that we can take the moment easily. So what I'm going to do here is I'll convert this rectangle. I'll convert this whole section into two parts. One is the rectangle, another is this triangle. Okay, for triangle, the load will be how can we convert a whole load into a point load? Whatever the load value will be, that will be at a distance of this L by 3. So if this total length is L, so the point load, we will show it at a distance of L by 3 from the from this end. Okay, from this end. Okay, the one which I am coloring with the violet color. Okay, so if the total distance is, let's say, 6, so this will be 2 meters. So this will be 6 over 3, which will be 2. So L over 3 from the 90-degree angle end. And then we also take the height. If I were to talk about the height, that height will also be h upon 3. So this will be h upon 3. So if the total height, this is 3 meters, so this distance will be 1 meter. This will be 1 meter, but we don't need to worry about the height in this case, because it's only the vertical loads which are acting on the system. So we don't need to worry about the height. All right. Similar sort of a situation gonna happen with the rectangular load. Right in the middle, it's gonna act. So if the total, this is 3 meters as it is mentioned here, so it will act right in the middle. If I were to convert it into a point load, so it will act at a distance of 1.4 meter from the each end in this case. All right, and how much the load will be, that's what we have to figure out. So again, if I draw this rectangle, this is 12 times 3, because 12 kilonewton per meter, so 12 times 3, that will be 36 kilonewton total, and that's gonna act right here in the middle at a distance of 1.5 meter from this end. 1.5 meter. Okay, and in this case, this is a triangle. If this is a triangle, so the load's going to act at a distance of the total length over which it is acting is 6 meter, so at a distance of 2 meter from the 90-degree angle end. All right, that's how we will measure the distances. So if I were to, now I'm going to erase this, I'm going to try to draw it in the form of point load. So here there will be a 36 kilonewton, 36 kilonewton downwards, and for this triangle it is again, uh, this is 12, this side is 12, because here I can see this is 12, and acting over a distance of 6 meter, 6 meters. So 12 times 6 multiplied by 1 half, that will be again 36. 36 at a distance of 2 meters from the 90-degree angle end. So 36 kilonewton again. And we will remove the this distributed load. So I'm going to redraw the diagram here. So diagram is going to look something like this. Let me show you the picture also. So this is A. I'll only take the RY because there is no inclined loads which are acting, so I don't need to worry about the X direction. And then down here I will write down as RB. This is a roller joint, and RBY, this is RAY, and this is where the load is acting, and another load which is acting somewhere here. Okay, I can draw it down here also. Line of action should remain the same. So this is the point I'll show it as. This is 36 kilonewton, and this is again 36 kilonewton. All right. Now I will measure the distance. This is 4 plus 1.5. This distance was 1.5. 4 plus 1.5 is gonna give me 5.5. So this is 5.5, and then this RB. So this is RB. So distance from here is, we've already, I guess, from this point it is 1. This is 1, and what else other distances are, uh, this one, yeah, that's pretty much it, I guess. So this will be 2.5. If you see this, yeah, 1 plus this is 1.5, and this is 1, so 2.5 will be this distance. All right, so we've drawn this, and the final distance will remain as 4, because the total is 6. It is over a span of 6, so this distance here to here will be 4. So this distance here is 4 meters. Now we just need to simplify this question. So taking moment about A, taking moment about A, that will be RB times RB times, this is gonna move it in counterclockwise direction, RB times 8 minus, so this one is rotating, this one first of all, this one is rotating in clockwise direction, minus 5.5 times 36, and then other is also minus 36 times 9 equal to 0. And once you're going to solve this value, RB value will come out to be 65.25 approximately once you're going to solve this equation. And then we're going to use the other one, taking moment about B, about point B. So let's B. So if I take the moment about this point, this is rotating in the clockwise direction, counterclockwise direction. So 36 times 2.5 is positive, and this is rotating in the clockwise direction, this load clockwise. So minus 36 times 1, and then RA is rotating in the clockwise. So RA is going like this. So minus RA times 8 equal to 0. So if you're going to solve for RA, that's going to come out to be 6.75 from here. So that's how you're going to simplify these questions. So hopefully you were able to understand. And yeah, so that's it from my side for this video. I'll see you with another video. Till then, goodbye.